Hi friends, welcome to SV Technology. In this video, we are going to discuss shift micro operations. In last class, we have discussed arithmetic micro operations and logic micro operations. So if you are visiting this channel first time, please do subscribe to my channel. So ఈ వీడియోలో మనం షిఫ్ట్ మైక్రో ఆపరేషన్స్ గురించి నేర్చుకుందాం. ఓకే, షిఫ్ట్ మైక్రో ఆపరేషన్స్ ఆర్ యూజ్డ్ ఫర్ shifting the contents of register one bit at a time, either left or right. Simply what is mean by shift mean? Shifting. Okay, shifting the bits of register either left or right at a time. So ప్రతిసారి ఒక బిట్ ని మనం షిఫ్ట్ చేయగలం, అది కూడా either left షిఫ్ట్ చేయగలం లేకపోతే రైట్ షిఫ్ట్ చేయగలం. So in shift micro operation, basically we have two types of shift micro operation. That is either left shift చేస్తే left micro operation అంటాం దాన్ని, ఒకవేళ రైట్ షిఫ్ట్ చేస్తే దాన్ని షిఫ్ట్ రైట్ మైక్రో ఆపరేషన్. సింప్లీ I have a register with content 0 1 1 1 0 1. So the last bit will be called as least significant bit. Okay, and this is also called as rightmost bit. Okay, and this leftmost bit అంటే left side last ఉన్న bit మనం ఏమంటాం most significant bit. This is called as least significant bit and this is called as most significant bit. Here I am performing left shift micro operation. Means the register contents will be shifted each bit at a time. This one bit will be shifted to here. Okay, this 0 bit will be shifted to here, and this 1 bit will be shifted to here, and this 1 bit will be shifted to here, and this 1 bit will be shifted to here, and this last bit MSB bit means most significant bit will be discarded. Discarded means deleted, and here we have a vacant, right? So this vacant position will be filled with 0. The LSB is filled with 0 and the MSB is discarded. This is shift left operation. Okay, this is called serial input IL. Okay, the newly inserted bit is called as vacant position is called as serial input, that is IL. We will use this IL in future. Okay, remember this. And so in shift right operation, every bit will shift to right like this. This 0 will be shifted to 0 and this 1 will be shifted to here, this 1 will be shifted to here, this 0 will be shifted to here, this 1 will be shifted to here, and in last shift left operation MSB is discarded, but here LSB will be discarded. Least significant bit will be discarded and this vacant place will be filled with 0. This vacant place will be occupied with 0. That is called serial input IR. In right shift operation, if you fill MSB with 0, it is called IR, input right. So here it is IL, input left. So this is the basic shift right and shift left micro operations. Okay, in shift micro operation we have multiple types. Here we can see types of shift micro operations. Okay, types of shift micro operation. In shift micro operation mainly we have three types of shift micro operation. First one is logical shift micro operation. Second one is circular shift micro operation. Third one is arithmetic shift micro operation. And in each type we have two subtypes. In logical shift micro operation we have logical left shift micro operation and logical right shift micro operation. In circular shift micro operation we have circular left shift, circular right shift. In arithmetic shift micro operation we have arithmetic left shift, arithmetic right shift. Like this, we have total 6 types. Okay, including subtypes, we have total 6 types. Here, we will see how we are going to represent all these 6 types. Okay, here you can see the table related to that. So, SHLR means shift left. Okay, logical shift left register R. SHL means shift left. SHR means shift right. CIL means circular shift left. CIR means circular shift right. ASHL means arithmetic shift left. Next, ASHR means arithmetic shift right. So here capital R represent the register. Register bits will be shift right. Register bits will be shift left. Here register bit will be shift arithmetic shift right. Okay, we will discuss everything clearly about these types one by one. Okay. Here we will discuss first type, logical shift microoperations. In logical shift microoperation, it can be defined as shift of the bits either left or right serially, and normally 0 occupies the vacant position and LSB or MSB will be discarded. And it is mainly 2 types, you know that already. Logical shift left, it is represented with SHL, and logical shift right, it will be represented with SHR. Okay. Next, we'll discuss about logical shift right. So we have a register bits like 101, 011. Here shift right means every bit will shift one position to the right. This one will become placed here, and this 0 will placed here, and this 1 will placed here, and this 0 will placed here, and this 1 will be placed here. And this LSB in shift left operation, in shift right operation, LSB will be discarded here, and this MSB will be filled with 0. We called it serial input L. Okay, IL and chapkunnam kada adi. So every bit gets shifted towards right. The rightmost bit means LSB gets discarded, means deleted, and 0 fills the vacant position, MSB position. So here I have filled 0 with vacant position. Mathematically, this operation shows that the number is divided by 2, and this will be represented as this. SHR means shift right register to R, replace it R1. R1 means register. Okay. So like this, shift right operation will be there. Logical shift right operation. Okay. Next, logical shift left. It will be represented with SHL. So here every bit will be take one position left. Okay. So here 1 will be placed here, and this 0 will be placed here, and this 0 will be placed here, like this. Okay. This, and this. And MSB will be discarded, and this LSB will be vacant position will be replaced with 0. Okay. Mathematically, this operation shows that the number is multiplied by 2. Left shift operation shows multiplied by 2, and right shift operation shows divided by 2. Whatever the number you have given, after the left shift operation, it will be multiplied by 2, and after the right shift operation, it will be divided by 2. Answer will be divided by 2 answer also. Next, circular shift micro operation. Okay, circular shift micro operation ante It is also known as rotate shift microoperation. It circulates the bits among the register bits without losing the information. We can achieve this by connecting the output terminal to the input terminal of the register. So, when DS idea unnatlaite, it is like circular linked list. And the first bit or last bit will be connected each other. Okay, I mean output terminal, input terminal connect ayi untayi annamata. Okay, we will discuss clearly, don't worry. So circular shift micro operation anedi main ga two types untundani cheppunnam, that is circular left shift micro operation and circular right shift micro operation. Okay, circular left shift, so it will be represented with CIL. Okay, so here every bit will be transfer left side, and the most significant bit will be connected with least significant bit. ఇంత ముందు ఏం చేసాం, మోస్ట్ సిగ్నిఫికెంట్ బిట్ అనేది డిస్కార్డ్ అయ్యేది అండ్ లీస్ట్ సిగ్నిఫికెంట్ బిట్ అనేది జీరో అని రిప్లేస్ అయ్యేది. కానీ ఇక్కడ ఏమవుతుందంటే మోస్ట్ సిగ్నిఫికెంట్ బిట్ లో ఏదైతే నెంబర్ ఉంటుందో, ఏదైతే బిట్ ఉంటుందో, that will be connected with least significant bit. Okay, so here every bit will be shifted one left side like this, and the MSB bit will be connected to LSB bit, and this will form a circle shape. Okay, that's why this is called as circular left shift. Next, every bit gets shifted towards left. The leftmost bit means MSB, okay, is assigned to the rightmost bit LSB. Okay, so this is circular left shift operation, and it will be represented with CIL. Next, circular right shift operation, it is represented with CIR. Okay, here every bit will be shifted right. Okay, one bit right shift అవుతాయి, one place right shift అవుతాయి, and the LSB actually అయితే discard అవ్వాలి కదా ఇది. This LSB will be connected with MSB. Okay, this LSB one here, it will be connected with MSB. Okay, and it forms a circle. So it is circular right shift. It is represented with CIR. So I have given here that only every bit gets shifted towards right. The rightmost bit means LSB extracts and get appended to the leftmost bit MSB. Okay, next, arithmetic shift micro operation. So here we have a small problem, we will discuss about that. Okay, arithmetic shift right micro operation. సో ఇంతకు ముందు మనం చెప్పిన ఆపరేషన్స్ అన్ని కూడా పర్ఫార్మ్ అయింది దేని మీద అంటే స్ట్రింగ్స్ మీద. But arithmetic shift micro operations will perform on binary signed numbers. Okay, in this operation we have to take proper care, otherwise you will lose some data. Okay, for shift left, contents of registers multiplied by 2. For shift right contents, the register is divided by 2, as we discussed earlier also. So the arithmetic shift must leave sign bit unchanged. Arithmetic shift is two types. So సింపుల్ గా ఒక కండిషన్ మీరు గుర్తు పెట్టుకుంటే ఈ arithmetic shift గురించి రాసేయచ్చు. అదేంటి అంటే బిఫోర్ ద ఆపరేషన్ అండ్ ఆఫ్టర్ ద ఆపరేషన్ sign bit must not change. Okay, before the operation sign bit and after the operation sign bit should be same. Why? Because if we are talking about number, if it is most significant bit is 0, it is positive number, and most significant bit is 1, it is negative number. So before the operation and after the operation it should be same, either positive or negative. The number must be same before the operation. Before the operation if it is positive, after the operation also it should be positive. and if before the operation it is negative number, after the operation also it should be negative number. Okay. Arithmetic left shift operation is mainly two types. Okay. So arithmetic shift micro operation is mainly two types. One is left shift and right shift. Left shift, arithmetic left shift will be represented with ASHL, and arithmetic right shift operation will be represented with ASHR. Here we will discuss arithmetic shift right operation first. Okay. Here MSB bit always represent the sign of the number. That is, if it is 0, that is positive number, and it is 1, it is negative. So here in right shift, every bit will be shifted towards right. Okay, like this. Okay, and the sign bit remains same. We are not going to discard this one. Okay, we are not going to discard this one, or we are not going to replace this with 0. We must replace this with whatever the sign is. Okay, so in arithmetic shift right operation, we don't get any problem. The LSB will be discarded and the vacant position will be filled with the sign bit. Okay, here vacant position will be filled with the sign bit. Anyway, it is a most significant bit, so we don't get any problem here. But while doing arithmetic shift left operation, we will get a problem. So what is that problem? We will discuss here. So in arithmetic shift left operation, so we are shifting the bits to the left. Then MSB bit, here 1 is there and here 0 is there. This 0 will be replaced with MSB. Means the earlier, before the operation, this number is negative number. Why? Because MSB is occupied with 1, so it is negative number. But after the operation, the MSB is occupied with 0, means positive number. But we have read a rule before this, the sign should be remain unchanged before the operation and after the operation, sign should be same, but the condition is crossed here. Okay, condition అనేది ఇక్కడ వర్కౌట్ అవ్వలేదు అన్నమాట. So in this example, before performing arithmetic shift left operation, the number is negative number, and after performing arithmetic shift left operation, the number is positive number. So practically it is not possible, as we studied in a earlier rule, because arithmetic shift must have sign unchanged. మనం arithmetic shift ఎప్పుడు చేసినా కూడా సైన్ అనేది చేంజ్ అవ్వకూడదు అని మనం చదువుకున్నాము క్లియర్లీ. ఓకే, సో arithmetic shift left operation is used nowhere in processors. సో ప్రాసెసర్ లో ఎక్కడ కూడా we don't use arithmetic shift left operation. Okay, here we have a small topic called sign reversal. So what is mean by sign reversal? Before the operation, the number is positive number, and after the operation, the number is negative number. This is called as sign reversal. Okay, if the sign of a number change before and after the operation, it is called sign reversal. And we have an overflow condition here. It can be occur arithmetic shift left operation. Before the operation, sign bit is 1, and after the operation, sign bit is 0. In this situation, overflow can occur. Overflow occurs when last two bits are different. If there is last two bits are different, then only you will get overflow or sign reversal condition. If the last two bits are same, there is no problem. Okay, why? Because before and after the operation, signs will remain same. If both bits are same, last two bits are same. Okay, here we will see hardware implementation of shift micro operation. Okay, here we have S0. This is control signal, and we have 4 outputs: H0, H1, H2, H3. Okay, so I will discuss clearly about this. You know that what is IR, serial input write, and you know that what is IL, serial input IR. Whenever I shift write, most significant bit will be replaced with IR, you know that, and the next position will be, means A0 position will be shifted to here, and A1 will be shifted to here, and A2 will be shifted to here, and A3 will be discarded. Why? Because this is least significant bit. This is 4-bit register I am talking about. A3 will be discarded. So if I am talking about left shift operation, least significant bit will be filled with vacant position. This is called, this will be filled with input left, serial input left IL, and this A0, the first bit we call it A0, right? A0 will be discarded, and that will be replaced with A1, and A1 will be replaced with A2, and A3 will be, A2 will be replaced with A3. Like this, we will form a function table. Okay. Based on this function table, I am going to build a 4-bit shifter hardware implementation. Okay. Here we have serial input IR selection line S0. Why? Because we have only two options. It should be either left shift or right shift. So one selection line is enough. One is IR and one is IL, and one will be A0, A1, A2, A3. So A1, A0, A2, A3, A1 లో నుంచి 1 bit will be taken as input, okay, and selection line will be taken as input. So I am taking multiplexer 2 by 1, means it will take 2 inputs and it will give 1 output, either H0, H1, H2, H3. So like this hardware implementation will be there. Okay, so this is all about shift micro operation and its types. So for more information like this, please do subscribe to my channel and follow me.